Pascal's triangle is really easy. That's not a hard thing. It's the binomial expansion that can sometimes be a bit tricky. So Pascal's triangle, it's just a pyramid of numbers pretty much. It goes on forever and ever. The top of the pyramid has just the number 1. The next row has a 1 and a 1. That's row. Now you really need to notice how I've numbered the rows. It seems strange right now, but just write it down. The very top of the pyramid is actually called row 0. I'll show you in a second. The next row is called row 1. The next row is 1, 2, 1.
Oh, this thing.
You've seen this before?
Yeah.
Okay. This is called row 2. Even though it's the third row of the triangle, it's called row 2.
Like most elevators and stuff there, like ground level is called floor 0.
Yeah, in Europe that's how it is.
1, 4, 1, which makes sense if you think about it.
Yeah, yeah. That took me a little while to get used to when I was in Germany.
It's like, with our logic, you're born and it's your first birthday, which is inaccurate.
Here's the next row, 1, 3, 3, 1. Now you guys, these are not just random numbers. There's actually a pattern here. And unless you know the pattern, you're not going to be able to successfully complete this lesson. So take a look at the triangle, see if you can see the pattern. You're close. So most of my students yesterday said, and it's the same thing you said, and I understand why you say it. A lot of students say, well, the next row is going to be 1, 4, 4, 4, 1. But it's 1, 4, 6, 4, 1. Not yet. For those that know the pattern, just hold off on a second. And this is not something that's just nice to know. You do need to know this pattern because you have to use Pascal's triangle to solve binomial expansion problems. So unless you know the pattern, good luck solving these. That's all I'm telling you. So we went from 1 to 1, 1, 1, 2, 1, 1, 3, 3, 1. But now all of a sudden it's 1, 4, 6, 4, 1. And before I show you, I'm just going to tell you what the next row is. It's 1, 5, 10, 10, 5, 1. The next row is 1, 5, 10, 10, 5, 1. Where are those numbers coming from?
From the numbers from the...
Take a look at, you see what number I'm circling? 3? What are the two numbers right above it on either side? 1 plus 2 is 3. You see where this 3 is? What are the two numbers directly above it? 2 plus 1 is 3. Do you see this 4 right here? What are the two numbers directly above it? 1 and 3. What's 1 plus 3? 3 plus 3? 3 plus 1? Do you see what the pattern is now? So what would the next row be? 1, 5, 10, 10, 5, 1. And I don't have it written. This is where I stopped. But what would the next row be?
1, 6, 15.
Yep. You do need to know probably up to the 6th or 7th row of Pascal's triangle. Okay? I stopped writing at row 5 because I probably got a writer's cramp or something. But anywho, that's Pascal's triangle. That's really all you need to know for Pascal's triangle. But this is the most important part of the lesson. He's not a lizard. A binomial is an expression with two terms. That's what the word bi means. Bi means two. So we've seen a ton of binomials. X plus 5, that's a binomial. 2x minus 3, that's a binomial. Anything with two terms is a binomial. You want me to hold on to those for you? Would that help you pay attention better? Oh. You're asking him to hold on to it for you?
I should.
Yeah. So here's a binomial, a plus b. Write that down. It's got two terms, a plus b. But that's just a binomial expression. We're talking about binomial expansion. That means you take the two terms and start raising them to powers. So let's start real easy. A plus b to the power of 0. What's a plus b to the power of 0?
I'm tricking her.
Anything to a power of 0 is... There we go.
Well, I put it out, so I wanted to give people a chance.
Anything raised to a power of 0 is always equal to 1. Doesn't matter what's being raised to the power of 0. It's equal to 1. Right, Mason?
0.
Except for 0 to the 0 power. Let's do the next one. Let's see if...
Did you say dry? Yeah. Oh, no, I saw that.
What's a plus b to the first power? Come on, come on, come on, come on. What's a plus b to the first power? It's a plus b. A plus b. Anything raised to the first power is exactly what you started with, so it's a plus b. This is binomial expansion. We're taking a binomial and we're expanding it with the power. So far, it doesn't seem that bad, right? What about a plus b squared?
A squared plus b squared. No, just kidding. It's a plus b.
Now, it's not your guys' fault, so I'm not trying to sound condescending here. But at no point ever in any single math class has a teacher ever taught you that a plus b squared is equal to a squared plus b squared. This is just stuff that students make up. Okay, this is not a true statement. Okay, you guys understand what I'm saying? Nowhere at any time has this ever been taught to you, and I understand that it's tempting to just try to distribute the exponent, but you can't do it. Okay, you can't do it. A plus b to the second power means there's an a plus b multiplied by what? Another a plus b. That's equal to a squared plus 2ab plus b squared. That's what you would get if you used the FOIL method. So now the binomial expansion is getting a little harder. A plus b squared. It wasn't quite as simple as just the other two. What about this one? Is it going to be a to the third plus b to the third? No, it's not. Not even close. Doesn't a plus b to the third power mean there's 3 of those things?
Yeah.
What would you have to do with this to expand it all out?
You can combine like the last two and then.
We already know that the combination of the last two is equal to this, right? Exactly. So let's take one of the a plus b's and multiply it by this. Isn't this 2 of the other a plus b's? So now what would you do though?
Do the same thing.
Now you'd have to distribute, right? Or use the FOIL method. Now just for the sake of time, we're cutting it kind of close here. I'm pretty sure most of you could get by doing this by hand, but just let's skip right to the end. It's going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. That's what you would get if you multiplied that all out and combined all your like terms. We don't have time for me to show you, but just trust me, that's what you would get. All right? What's the connection with Pascal's triangle? What's the coefficient of A right here? What's the coefficient here? What's the coefficient here? What's the coefficient here? Go back up a step. What's the coefficient here?
1, 2, 1.
Go back up a step. What are the coefficients of both of these?
1 and 1.
And obviously that's just a 1. What does this resemble? 1, and then a 1 and a 1, and then a 1, 2, 1, and then a
1, 3, 3, 1.
1, 3, 3, 1. Here's why they numbered the rows so weird. What was the top row of Pascal's triangle called? Why was it called row 0? Anything raised to a power of 0 equals? The next row was called row 1 because the exponent here is an exponent of 1. So where this is going, you do not have to, well, after we finish the lesson, hopefully you won't have to, if it's a plus b to the 4th power, you're not going to have to write out 4 of those a plus b's and multiply it all together because that would take forever. You can use Pascal's triangle. Now, it's a little more complicated than that. It's not just the coefficients that follow a pattern. Take a look at the exponents. You guys, I need you with me for 5 more minutes. What's the exponent of A? What's the exponent of A? What's the exponent of A? You see a pattern here? The last term doesn't have an A because it's just A to the 0 power. And what is A to the 0 power? Now go backwards. What's the exponent of B? What's the exponent of B? Exponent of B? And how come there's no B term here? Because it's power of 0. You following? The goal of this lesson is to be able to do this kind of a problem right here. So let me show you what the next problem is. A plus B to the 4th power. But the goal is to be able to do this without having to write it out A plus B 4 times and multiplying it using the FOIL method. The goal is to use both Pascal's triangle for the coefficients and noticing the pattern of exponents. All right? What do you think the first term is going to be?
1.
The coefficient is going to be 1. And what's the term going to be? A to the 4th. And technically there's a B to the 0 term, but we don't need to write that, correct?
They're always positive?
Yep.
Well, okay.
Exponents are always positive. Now what's the next term going to be? Refer to Pascal's triangle in row 4. What's the next coefficient? 4. So it's going to be a 4, A to the 3rd, B to the 1st power. You with me? What's the next term? 6. A squared, B squared. What's the next term? 4 and then A to the 1st power, B to the 3rd power. And then the last term is 1 times B to the 4th. So we just expanded without having to use the methods we use in the problem above. This is using Pascal's triangle to get all of the coefficients. 1, 6, 4, or 1, 4, 6, 4, 1. And then you have to remember the pattern of exponents. Okay? We'll have to take a little more time to practice this next time. But this is essentially it. The only thing that's going to change is on your homework, it's not going to be A plus B. It might be something like x minus 5 or 3x plus 4, just different binomials. And we'll practice that next time. But that is about it for today.